So next function is to get the orientation, and to get the orientation basically we are passing IP, IMG and verbose. Again here you can remove all these comments and you can tell this Gauss 25. Now Gauss 25 has this special Gaussian format, and basically this Gauss 25 all the rows here they are arranged in a different row and matrix format, but then you convert them into a single row format. So where these points have came from, so this is basically a Gaussian filter applied, and it has those values, and if you solve by that formula 1 over root 2 pi sigma square, you will get these same values. Now if you pass this Gauss 25, again you round all the x y values and the scaling factor values. So throughout this function we are rounding off x position, y position and the scale, because that's how this function Opensurf works. Then calculate the Haar responses within the radius of 6. So basically you check the 36 pixels around the original pixel, and then j equal to j colon I equal to I colon check. Now you take a Euclidean distance less than 36, and then if it matches, then Gaussian filter by mirroring the Gauss 25. So you put this ID 6542, so it's a symmetric ID of 36 terms, and basically Gauss 25 you pass this ID, and then 7 plus 1 times you multiply, then residual x you pass this new Gauss filter, which is the image filter, now mirrored image filter. You take a Haar x of the image, then you multiply it with s term, that is a scaling term, x plus I, and that is a shift in x, so that's why you calculate the residual x and residual y. Once you get this residual x and residual y, you calculate the angle by taking inverse tan inverse of the parameter res x by xy, and then the window around the feature box you want to put, so you take that angle and multiply it with a radius of 0.25 2 pi, and then modulus of angle plus 3 2 pi. So you will have two angles. Now repeat check whether all the angles are correct. So with the corresponding responses in y direction for loops, Cx equal to length of the angle, Ci equal to length of angle 1, then repeat map the angles and again calculate the Rexy and Rex. Now if your angle 1 is greater than 2 and angle 2 is greater than angle, and angle 1 is greater than angle 2, that is the first check we are doing, and angle 2 is greater less than angle 1 and angle is greater than 0 and angle is less than angle 2, or the vice versa. तो 0 to pi के बीच में है एंगल, और एंगल 1 और एंगल 2 के बीच में, that check we apply, and then final check equal to check 1 plus check 2, and then you multiply it with that check, so it is either 0 or 1. So sum of residual, so जब भी वो check satisfy नहीं होता या 0 to 2 pi के बाहर चला जाता है एंगल, हम उसको 0 कर देते हैं, मल्टीप्लाई करके छोड़ देते हैं, and then you take a Euclidean distance square of some x and some y, and then again take the inverse Laplace tan inverse of y by x of indices all the orientation controls, and then px equal to 0 13, 13. So here you put that angle and try to rotate the function, and finally you draw a circle at the same pica location, and this is how this function works.